what is a function? The definition says a function is a rule to know what is a domain and what is range. Honestly, I have already explained it to you, but let's just understand it again. Next we have mapping. So what is mapping? Basically, whenever a function is given to us and we draw this thing, right? Types of functions, right? So broadly we have 4 types of functions. Welcome students, welcome to another class. In this class, we are going to continue with our chapter functions. As you remember, in the previous class, we studied basics of functions, types of functions. Now, what were the types of functions? There were one many, many one, and many many. We also discussed that one functions and one many functions are actually my functions, right? And we also discussed that trigonometric ratios are also functions. Now let's move ahead with the next topic of the functions. And the first topic that we are going to study today is inverse of a function. Now, what do you mean by inverse of a function? We are just going to deal with the graphs, all right? I'll also tell you how to find the inverse of a function, but the majority of the questions we'll be dealing with will be related to graphs, all right? Now, what is an inverse function related to a graph? The graph of y equals to f of x and y equals to f inverse x are reflections of each other in the line y equals to x. But remember one thing, whenever you are reading it, right, do not read it as f raised to the power minus 1. We are used to reading it as f raised to the power minus 1 because we are very much used to dealing with, like polynomials. This is not a polynomial we are dealing with. We are dealing with a function, and when we are dealing with functions, we read this as inverse, right? So f inverse x. All right, now I have drawn a graph here, right? So this was my function. You can take any of this was my, let's say, initial function, right? Y equals 2x minus 2 over 3, and I had to find the graph of inverse of this function, right? So what I did was I just reflected the blue graph in this dotted line. This dotted line is my y equals to x, and when I'll draw when I'll reflect this graph in this dotted line, I'll get this orange graph, and that is the graph of my inverse function. All right, so whenever you are dealing with such questions, always just take the reflections. Now many of you might ask, sir, how to do that, right? So the first thing is we just need 2 points. If we are dealing with linear graphs, right, we just need 2 coordinates, correct? One of the coordinate is very obvious, that is the intersection of the blue line and the dotted white line, correct? Now another thing that you can do is just find the coordinate of this point, or any point for that matter. It doesn't matter which point you are talking about, right? So whenever we are dealing with such thing, we will read this note. Now what does this note say? Reflecting in the line y equals to x has the effect of switching the x and the y coordinates. Now what do you mean by that? Let's say the coordinates of this point is 3, 2. Let's assuming, might be, might not be exact, but I'm assuming that the coordinates of this point is 3, 2, right? So when I'll take the reflection of this point now, so the coordinates of that point is going to be 2, 3. So that should be somewhere here, not exactly, but fine. So it should be 2, 3. That's what my reflection in the line y equals to x means. Whenever I'm taking the reflection of any graph in the line y equals to x, what I'll do is I'll just interchange the x and the y coordinates with each other. All right, and by doing that, I'll find the coordinates of the inverse function of the graph. All right. Okay. So please note it down and make sure you are noting down this note. It's very, very important. All right. So please note it down. Moving on to the next one. And we have a question. Now, what does the question say? Find f inverse x when fx equals x over 3 plus 4. Right. Now, we'll be dealing with this particular question in two different ways. All right. The first way is the way that we just studied, that is, we'll draw the graph of this function and then we will reflect that graph in y equals to x axis. All right. Now, the second function is, or sorry, the second method is, we'll be finding the inverse of this graph first, right? We'll be finding the inverse of this function and then we will plot it. All right. Now, first, let's start with the first method, that is plotting this. I hope everyone is aware on how to plot a graph, right? And since this is a linear graph, just 2 points are going to suffice, right? All right. Now, let's put x as 0. I'll get y as 4. Yes. Now, let's put x as minus 3. All right. And I'll get y as minus 3 over 3 is minus 1 plus 4 is, right? So, what are the coordinates? 0, comma 4. So, let's name them first. 0, 1, 2, 3, 4. Sorry, my bad. This is 0, 1, 2 and 5. Minus 1, minus 2, minus 3 and minus 4, right? So, 0, comma 4 is here, right? And the next one is minus 3, comma 3. So, somewhere here, right? All right. Now, if we'll draw this, what you will get? So, you should get something like, all right, something like this. Very difficult, you know. Okay. You should get something like this. And that is my graph of the given equation. All right. Now, what I'll do is, I'll draw the line y equals to x. Okay. And the line y equals to x will be something like this. Again, dealing with this is quite a problem, you know. All right. Not exactly, but fine. Let me my color. Right. So that's my line y equals to x. All right. Now, to plot the inverse, what I'll do is, I'll just flip them. Okay. See, taking the reflection is not a very good idea always. So what you can do is, just switch them around, and rather than 0, comma 4, you'll get 4, comma 0 and 3, comma minus 3. So just plot them. 4, comma 0 will be somewhere here, right? And 3, comma minus 3 is somewhere here. So if I'll join these two, I should get something like this. That not exactly but something like that should be my curve. Let's use a different color. All right, so something like this, right? That's what my graph of the inverse function of x over 3 plus 4 should look like. All right, so that's the first way. So I hope it's clear. Note it down. All right, moving on to the second method, and the second method is by finding the inverse function first and then plotting it. So my function was y equals x over 3 plus 4. Now first let's deal with how do we find the inverse function. Right now the equation is given as y in terms of x, right? Now we'll do the reciprocal, not exactly reciprocal, the reverse. That is, we'll find x in terms of y, right? So we'll shift the 4 here and I'll get x over 3 equals y minus 4, and x equals 3 times y minus 4. Now just interchange the x and the y. So y is equals 3 times, or I can say y equals, this is my inverse function. All right, see, it might look like it's hard, but actually it's not, right? I just figured out the equation x in terms of y, and then I interchange the x with the y, and that's my answer. That's it. All right, now I just have to plot this equation, and plotting it is again my cup of tea. So x and y, please do not put x as 0, right? Please don't do that. It will be very really illogical to do that. All right, now let's put x as 4. I'll get y as 0. Let's put x as 5. 15 minus 12, I'll get y as 3. Now let's plot them. 4 comma 0, we all know that 1 2 3 4 and 5, 1 2 3 4 and 5. So 4 comma 0 and 5 comma 3, that was my 2 points, and if I'll plot them, right, what I'll get, okay, so something like this. All right, might not be a perfect one, but still get it what I'm trying to say, right? So that's what my graph will look like. Actually the graph of the inverse function would look like. So this is the graph of f inverse x, or you can write it as 3x minus 12. All right, so that's my first question using two methods. You need to only figure out one method that matches you, that fits your working style. You don't have to learn and remember both of them. Just try and like get a good grasp on any one of them. All right, please note it down. Moving on to the next one, and we have another question. All right, the question is, state the range of the function fx equals square root of x minus 1 for x greater than equals to 1. This, my students, is the domain. The values of x for which the function is defined is my domain, and if you'll notice here, if you'll put any number less than 1, right, So I'll get a negative number inside the square root and which is not defined. So that's why x greater than 1, greater than or equals to 1 is my domain, right? So to find the range, what I can do, when I will substitute anything here, right? Anything, you'll get a positive answer, right? Whether you'll substitute 1, 2, 3, 4, 5, 6 or anything, you'll always get a number 0 or greater than 0. So my range is fx is greater than equals to 0, right? For x greater than equals to 1. All right. Okay. Now the question says state the domain and the range of inverse of x. Now there is a very easy, like way to do this. The domain of fx becomes range of f inverse x. I'll explain the logic also. All right, and range of fx becomes domain of f inverse. Now what is the logic? Domain is the basically the x values and the range is the y value, right? So didn't we say that the x and the y got interchanged when I was finding in the previous question, when I did this, right? And in the next step, what did I do? I interchanged the x and the y values. So the same thing is happening here. So the x value became the y value and the y value will become the x value. And this is very, very important. I always just need to figure out the range and the domain of fx, and by interchanging the domain and the range I can easily figure out the domain and the range of f inverse x. I never need to find both of them, just the domain and the range of fx is enough. All right, please note it down and please note this thing positively. All right, moving on to the next one, and my next is what? Composition of functions. This is a very important topic. Many past year questions have come from this particular topic. All right, now what is composition of functions? When two functions are used one after the other, the single equivalent function is called as the composite function. All right, composite always means a complex thing or a thing comprising of more than one, right? So composite function is a function which comprises of more than one. It can be two, it can even be three. We'll be taking both the examples of two functions and three functions. All right, now I have given a very small example here. If fx equals to 3x plus 2 and gx equals 2x minus 3, then the composite function gfx, all right, you read it as g of fx or gfx, it's completely fine, is obtained by applying f first and then applying g to the result. So always start from the right end. And which function do we have first? F. So we will be applying f first. Now how do we do that? G brackets fx. What is my fx? 3x plus 2. Correct? Okay. Equals to. Now gx was what? 2x minus 3. Yes. If we have a x here, we have a x here. If I have t of 3x plus 2 here, so this x should be replaced by hold on, 3x plus 2. Now I was saying, if it's x here, we have a x here. If I have a 3x plus 2 here, this x should be replaced by what? 3x plus 2. So I get 2 times 3x plus 2 minus 3, and that is what? 6x plus 4 minus 3, and that is what? 6x plus 1, and this is the value of g of fx. You can even use the brackets or you don't, it's totally up to you. All right, like this we can definitely write it. All right, so that's how I'm gonna solve composite functions. Okay, please note down the definition if you want to. If not, at least write the question down, write down the solution just for your own reference. All right, moving on to the next one. And now we have 4 parts of a question, and if you'll notice, the parts C and the part D comprises of 3 functions at a time, right? So let's start. Given that fx equals 2x, find gx equals to x square and hx equals 1 over x. Actually this is a very simple question. Reason, there are only one term in each of the function. Now what does the first part say? F gx or f of gx. So f of gx, that is x square, correct? Yes. So that will be 2 times x will be replaced with x square, that is 2x square, correct? All right, moving to the part B, g of fx. So g of fx is 2x, right? Now this x with this x, sorry, this x will be replaced with 2x, and I'll have 2x whole squared, that is 4x squared, correct? Moving to the C and the D part, a bit more complicated but not that much. Now f of g of hx. So f of g of hx, what is my hx? 1 over x, correct? Now the x in the function g will be replaced with 1 over x, and I'll get f over x square, that is 1 over x whole squared, right? And that is equals to f of 1 over x squared. Now the x in fx will be replaced with 1 over x squared, and I'll be getting 2 times 1 over x squared, that is 2 over x squared, and that is my complete answer for f of g of hx. All right, moving to the part D, that is h of g of fx. So h of g of hx is 2x, correct? Now equals h of, now replace this 2x, sorry, substitute this 2x in this x, and I'll get 2x whole squared, that is h of 4x squared, correct? Now if I substitute or replace x with 4x square, I'll get 1 over 4x squared. Just notice the difference, 2 over x squared, 1 over 4x squared, and all of it just by interchanging the functions a little bit, right? If I interchanged, like f and h here, right? If you'll notice, f and h here, if I interchange the values, I'll get my D part, that is h of g of fx, and just by doing this I changed the entire answer. All right, so please note it down. Moving on to the next one, and the next topic is modulus function. Now, what are modulus functions? The modulus of a number is its positive value even when the number itself is negative. Alright, now what does it say further? The modulus is denoted by vertical line on each side of the number and is sometimes called the magnitude of the quantity. Right? Modulus, and we even call it absolute function or absolute value. Right? In some questions or some books, you might find the word absolute rather than modulus. All right, okay. Now next sentence said the modulus is denoted by a vertical line on each side of the number and it is sometimes called as the magnitude of the quantity. Now see this number, the vertical lines around, or like on the left and the right of the 28 denote that yes, we have to find the modulus of it and the number is 28 itself. But if let's say the number was minus 28, the absolute value would still have been 28. Basically, the absolute value or the modulus of any function always gives me a positive value. Whether the number is positive or it is negative, the answer is always going to be positive, right? Now let's read further. Modulus of x equals to x when x is greater than 0, and modulus of x is equals to minus x when x is less than 0. This actually confuses a lot of students. Why did we take this minus when in fact we are saying that it has to be always positive, right? Now let me just take both these cases separately. All right, okay, I'm erasing this one. Okay, now I said that modulus of x equals to x when x is greater than or equals to 0, right? Now take any value of x which is greater than 0. Let's take 4 for instance. So modulus of 4, and I'm taking this x on the other side, right? So modulus of 4 will be what? 4, and see 4 and 4 are equal, correct? Now let's take the second case. Okay, I'm taking modulus of x equals to minus x when x is less than 0, right? Okay, now modulus of x, let's take any negative value, let's say minus 3 for instance. So modulus of minus 3 should be equals to what? 3. Okay, and minus x minus, and I'm taking x as minus 3, so minus times minus becomes plus. That is why I have taken this negative sign, because when I'll take x as a negative value, there will be two negative signs which will give me a positive answer at the end, and that's what I want, right? I want the answer to be positive. And how to do that? By taking the quantity inside the modulus to be less than 0. It can be anything. Right now it was just modulus of x, that's why I took x less than 0. Let's say my question would have been modulus of x minus 2, right? Then what we'll do, the first case will be x minus 2 is greater than 0, sorry, and x minus 2 it's less than 0. When x minus 2 is greater than 0, what I'll get? I'll get, where to write? Okay, I'll get x is greater than equals to 2, and when I'll use this one, I'll get x is less than 2. In that case, that's what my inequality should look like. All right, so always bother about the entire thing inside the modulus. Take it, like greater than equals to 0 and less than equals to 0, and then find the value of x, for which you will change the definition to like minus or plus. All right, so I'll write like modulus of x minus 2 will open as x minus 2 if x is greater than equals to 2, or modulus of x minus 2 equals to minus of x minus 2 when x is less. All right. Okay. Please note it down. All right. Now let's read one more line, the last one first. Therefore, for the graph of the modulus function y equals to mod of x, any part of the corresponding graph where y is less than 0 is reflected in the x-axis. It's difficult to understand, but it's actually very easy. What did we say? That the answer is always positive, right? And what is the answer? The answer is the y value or the output, correct? And the output has to be positive, means what? Anything below the x-axis cannot be there, right? So what do we do is, any part of the graph that was below the x-axis, we will just like switch it and send it above the x-axis, or we say that it is reflected in the x-axis. All right, okay, moving on. Now we have a question here. The question is, sketch y equals to fx and y equals to mod of x fx on separate axes. That's why we have two graphs here, and the function is y equals x square minus 2. I know you can draw it on your calculator, but this question will not belong to the calculator exam. All right. Now the graph of y equals to x square is simply like this, something like, hold on, something like this. Okay, that is the graph of y equals to x square. Yes. Now I need to draw the graph of y equals to x square minus 2, meaning I'll just shift this graph 2 units down, and my graph should look something like this. That's what my graph of x square minus 2 should look like. Correct? Alright, that's the graph of y equals to x square minus 2. Now I have to draw the graph of y equals to mod of fx. So what I'll do is, the graph that was above the x-axis, I'll draw it exactly the same way. Hold on. Y is 0. Okay, it will be somewhat like this. When x is 2, y will also be 2, somewhat like this. Is correct. Yeah. All right. And the graph which was below the x-axis, that is, I'm talking about this part will be reflected and will become something like, all right, and that's what my graph of modulus of x square minus 2 should look like. All right, I hope it's clear. First I drew the graph of fx, right? Then I just reflected the part below the x-axis in the x-axis, and I got the graph of modulus of fx. All right, please note it down. Moving on to the last question for this chapter and the topic, sketch the graph of y equals to mod of 3x minus 5, right? Okay, for x between minus 2 to 3. So I'll just plot x from -2 to 3, that's it. All right, and for y we will plot them. Right, now first let's just plot for the normal function. Right, first we will just plot y equals 3x minus 5. Okay, and then I'll reflect it and I'll get the answer. So when x is 1, y is what? -2, I guess. Yes, and when x is 2, y is 1. Let's plot them. 1 comma -2, 1 comma -2, and 2 comma 1. Right, so my graph, hold on, yeah, this is a better idea now. Right, so my graph should look something like this. All right, now since I have to reflect this graph, what I'll do is I'll take this part, okay, not removable, so okay, hold on, yeah, and I'll just reflect this graph in the x-axis and I'll get something like this. Right, so this pink part and this yellow part is actually my complete answer. Right, now what does the next part say? On the same diagram, sketch the graph of y equals to 8x. All right, now let's plot y equals to 8x. When x is 0, y is 0, very obvious. When x is 1, y is 8. So it will be very steep graph. My bad. So it should look something like, let's use a different color now. Okay, so y equals to 8x should be something like this. Right, all right, now that is my second part, that is plotting y equals to 8x. Now we have a third part, and the third part is solve the equation 8x equals modulus of 3x minus 5. All right, let me tell you something. The yellow line above the x-axis is the part where this is positive, right? That is 3x minus 5. Yes, y equals to 3x minus 5. But this pink part was the reflection of the negative one. So this line is the graph of y equals minus of x minus 5. Correct? Alright. Now the third part says solve the equation this. Now it is reflecting, it is going to intersect my graph at 2 points. The first one, it's clearly visible, that is this one. The other one, it's not visible, but it's actually very obvious that the blue line and the yellow line are coming close as we go down the graph. So at some point they are going to intersect, right? So what I'll do is I'll find the intersection of the blue and the pink line and the intersection of the blue and the yellow line. Now let's do that. So my graphs were y equals to x, right? And for the blue and the pink line, right, it will be y equals to minus of 3x minus 5. Very obvious that the intersection of the blue and the pink line was y equals to minus of brackets 3x minus 5. So 8x equals minus 3x plus 5. So let's take it there and I'll get 11x equals to 5 and x equals to 5 over 11. So y equals to 8 times 5 over 11, that is 40 over 11. So my coordinate becomes 5 over 11 comma 40 over 11. That's my first one. The second one was the intersection of the blue and the yellow line. And the blue and the yellow line will be 8x equals 3x minus 5. So let's take it there and 5x will be equals to minus 5. So x is equals to minus 1 and let's substitute x as minus 1 and I'll get 8 times minus 1, that is y equals to minus 8. So my coordinate becomes minus 1 comma minus 8 and these two are the coordinates of intersection of the graph and the straight line. Alright, please note it down. Alright, the previous part also, yeah, note this down as well. Alright everyone, so that's it for this video. With this question, it ends our first chapter of Add Maths. So please keep practicing and thank you. But before that, please do not forget to like, share and subscribe to our channel. Thank you. If you had a blast watching, give us a thumbs up, share it with your friends and subscribe our channel to stay updated on all our future videos.